Okay, so what we're going to talk about here is estimating lean benefits. And one of the things that is, I guess it sounds kind of obvious, but certainly has been proven true, is that when we, our company as lean consultants, are able to do a good job of estimating the benefits of a proposed project, that typically those benefits are large, especially if we do a thorough job and we go out more than 1 year. Maybe we go out a few years, which is only reasonable, right? Those benefits, those improvements are not going to disappear after 12 months, hopefully. So when we start doing those kind of estimates, we typically get a large number, and typically customers are, I would say, a lot less nervous about signing up for an improvement project when they have some confidence that they're going to get their return on investment out of this effort, especially if you can take the estimated benefits and even cut them in half and it's still worth it, right? It's still good. So, so what we want to talk about here is the process of going through and estimating lean benefits. And by estimating, I'm meaning, what I mean to say is to quantify, right? Convert everything that we can into dollars. Not always possible, but that's what we want to achieve is some kind of dollar estimate for this particular lean project, right? And to do that, we've created a software tool called the Lean Benefits Calculator. It runs in your browser, and I'm giving you all free, unlimited access to this Lean Benefits Calculator. And I'll share with you the URL here in just a bit. I don't want you going off and playing with it too soon. So most of this webinar is going to be showing you how to use the Lean Benefits Calculator and the logic or the thinking that goes behind all these different categories of lean benefits. So I think you'll find this webinar useful. So here's the short agenda. We're going to talk about the importance of quantifying benefits and return on investment, introduction to benefits and commentary. I asked my good buddy ChatGPT to give me a list of lean benefits. So I thought we'd spend a couple minutes and just go down the list and see which ones are included in the Lean Benefits Calculator, which ones are more soft benefits or harder to quantify as a way of introducing the Lean Benefits Calculator. And then we'll go right into, I'm taking a risk here because I don't usually like to do this, but I'm going to try to demonstrate the Lean Benefits Calculator live. Okay. And actually, before I start, I was asked by Michael. Michael's my administrative assistant, marketing manager behind the scenes, keeping an eye on the chat. Oftentimes I'll be busy talking and lose track of chats. But if you have any questions as we go along, there will be someone from our side taking a look at the chats and responding to them. So I was asked by Michael to give a shout out to Airmar, I think it is Airmar Technology, and Kevin Hen. I guess you have a little group, gathered together in a conference room watching this. I don't know much about or anything about your company, Airmar. If it has anything to do with aerospace, then that's actually my background. Back when I had a real job, I was a marketing or material manager for an aerospace company here in Colorado called Ball Aerospace. You may have heard of it. It's not a small company. Okay, so with that, let's get going. So I've been getting a lot of good information actually from ChatGPT, working on presentations, white papers, and so on. And it's been doing a surprisingly good job of identifying things that I agree with, but I didn't necessarily think of, at least first pass. So this is a list of benefits that we might get from a lean initiative. And let's just quickly go down the list. So, and maybe comment on which ones would be quantifiable or not. So overproduction, that's one of the 7 wastes of the Toyota production system. Certainly that's going to be a benefit. And that's certainly something you could achieve. How you would quantify that, I think, might be a little hard. So I didn't include that per se in different ways through other benefits. So defects and rework, for sure. We want to quantify that. We expect our level of defects and rework, or quality, in other words, to improve as we go through a lean initiative. You'd have to have some idea of where you are today. You'd have to keep track of that today, actually, to be able to quantify it, but that's certainly on our list. Space utilization, floor space, for sure, that's on our list, because our manufacturing floor space is our most expensive floor space compared to contrasting with warehouses or other areas. And even if we don't need, because it tends to be sort of a sunk cost, even if we don't actually need more space, saving space, freeing up space, even if you have to block it off with police tape, is still of value, because that means we would be putting our existing footprint closer together, which is beneficial. Employee turnover, that is a big, can be a big expense in hiring new people and training them. That's not part of our lean benefits calculator, but that's certainly worth considering and maybe adding in the future. Okay, other benefits. By the way, I'm a big fan of playing around with, it's called DALL-E. There are other of these AI, image generators. And so I'm trying to spice up the presentation with AI generated images. Okay, what else? Inventory levels, that's a big one. So we actually, in the lean benefits calculator, we have 3 categories as shown here. We have raw material, we have finished goods, and we have work in process inventory that we want to look at. Lead times, for sure, that's a big one. So part of our goal in a lean initiative is to shrink the overall lead time, either from launch to finishing the product or even beyond that, right? From receiving a customer order or even receiving a customer request for proposal all the way to getting paid. That's probably the longest time frame, but we want to shrink that down. And I don't think it's appreciated maybe as much as it should be that the original inspiration from Taiichi Ohno at Toyota was really not so much to eliminate waste. If you look on the internet and ask for a definition of what is lean, what you often get back is lean is a philosophy and methodology for eliminating waste. Well, eliminating waste is good, but the primary focus from Taiichi Ohno and the Toyota people was actually designing a river system that tried to connect all the work together, all the way back to external suppliers, and shrink that time frame down by linking and balancing the work to get an even flow, just like a smoothly flowing river. That was the main goal. And of course, one of the ways to do that is you eliminate waste, but it wasn't the primary focus, the implication, today is that lean is all about that, right? The primary focus is eliminating waste, which is not quite correct. Okay, so number 8 is waste, for sure. We want to eliminate that. We haven't identified waste as a separate category in the lean benefits calculator because it's included in a lot of the other potential benefits. And production costs, yes, we will be touching on this more specifically. You'll see this when I get into the model. Downtime, I did not include, but again, another perfectly valid benefit. Energy consumption, I did not include either. So you can see ChatGPT is actually pretty good at identifying all these things that I hadn't actually considered, and they're all valid. It's just that they may be hard to estimate, especially energy consumption, but that's an important one. You may have noticed, or maybe not, behind me I have a screen. That's kind of my dashboard with my daily calendar and to-do list, and it has the weather and it has the time all on a little screen. But I'm mentioning it to you because it's running off a little Raspberry Pi, an old Raspberry Pi, which is a little credit card sized computer that consumes about 6 watts, something like that. So the energy consumption to keep that running behind me is quite low, and it turns itself off. Right, it turns on at 7 a.m. and it turns off at 6 p.m. I think. So that's an example of applying energy consumption savings to my local environment. And then resource redundancy, certainly we do talk about that. Talk about labor. All right. So a lot of good opportunities. And let me just say too that one of the benefits of being in the lean manufacturing or process improvement or Six Sigma world is that we can actually deliver benefits to either our company or our clients in ways that other types of consulting typically have a really hard time doing. I remember, I think it was a consultant from one of the major consulting firms I was chatting with at a conference some years ago, and he said, you know, we kind of know that we're adding value, but it's really hard to prove it doing the things we do. And one of the amazing things about Lean is, boy, those benefits are typically easier to prove and huge at the same time. So that's makes it easier for us to do what we do and get approval for it and be able to do that. Okay, one side comment here is I wanted to say a few things about the Lean Design Simulator. So this is not the benefits calculator. This is a simulator that we've actually developed that we included as part of our toolkit on the Lean Design Studio, which is our platform for mixed model manufacturing. And I'm mentioning it because in terms of estimating benefits, simulating a value stream, creating a computer model, in other words, a discrete event computer simulation model, is a great way to uncover benefits and prove them. So if your management team is doubtful about can we achieve this or not, having a model that actually shows them the before and the after and what you can expect when you make these changes to your processes is really convincing, I would say. And so we're big fans of modeling what we do. We're not fans of doing Kaizen events after the fact in order to fix things that should have been done right the first time. And I think you'd all agree with that. So modeling what we do or are proposing to do before we actually physically implement a design invariably ends up with a better design. But if you're trying to sell a project, either to a customer or to internally, to get funding to do what you want to do with this, then building a model is a great way of proving it, at least to a certain level, right? You may not believe the model, but at least, you have some hard data that comes out of the model, and it makes it, I think, a whole lot easier to sell. I'm talking about doing improvement projects like it's a sales job, but it is to a certain extent, because almost everything you want to do, at least at a minimum, takes your time. And so management is typically concerned about where their money is being spent. And if you can show, even if you're not a consultant, you work inside a company, if you can show that, hey, if we do this, we're going to get these benefits and results, then that's a very good thing. Okay, so let's get into it. I'm going to, maybe I shouldn't do this, but I'm going to share the URL with you. It is, it's a little faded here, but I think you can see it, right? HTTPS leandesignstudio.com and then / lean benefits calculator, LBC. And I've set up a public page for this software tool. Couple comments about it. The data is not actually stored anywhere. So it's just in your browser as you're using the tool. And so the only way we save it is at the end, you would click on send and it would send you an email. And then you can do with it as you wish. But I think that's maybe reassuring to some of you that may be asking the question, well, I'm putting in data from my company, presumably, where's that going? Or, how's that being stored? Well, the answer is it's not being stored at all. So if you don't say save and send me the email, you'll have to do it again. It's not that hard to use to do it again, but you probably don't want to do that. And this particular link here, I've set up on a different page. This tool is part of the Lean Design Studio, but Lean Design Studio is a membership site. So it's behind the membership firewall, but this is a public page. So you can get to this. And as long as we leave this, as long as our website exists, I guess, you'll have access to this and use it. I also noticed that our website seems to be slow today. So it's not down, but when you click on the link, it somehow takes a few seconds or more to load up. So don't be too concerned about that. I'll be looking into that and see why it's not faster. But okay, so what I'm going to do here is I'm going to switch over and I'm going to go to the Lean Benefits Calculator and try to do a live presentation. All right. and see how that goes. And so hopefully have a forgiving audience here if things don't work out trying to do things live. Okay, so here we are. And what I'm showing you here on the screen is the Lean Design Studio. So I thought I'd go in through that route just so you can kind of see what we have out there. So it's a website, and you notice there are different menu items here, tracks. And our main focus with Lean Design Studio is the main focus of our Lean practice, which is how do we help our clients redesign their assembly lines or their value streams in line with basic Toyota production system principles, or what we're calling mixed model manufacturing. And this is especially applicable to companies that are building families of products on the same line. So similar products, but just give you an example, air conditioners, you may have 10 different models and different sizes, but basically they're all going down the same line. And this is how Toyota builds their cars or builds their fork trucks in Columbus, Indiana. I'll tell you a little bit about that later. But in Columbus, fork trucks, which by the way have a much higher level of variation than automotive, they have something like 50 different base models, with different fuel systems, electric, gas, diesel, you name it. And then all these, on top of that, they have like maybe 50 different options and different capacities, lift capacities of the fork trucks. And they do have more than one line in Columbus, Indiana, the Toyota material handling factory. But on their main line, most models will go down the same line. And they're producing something like 180 a day on that one main line. And then they have some other lines for the more difficult models, like the very high capacity didn't fit very well in the main line. And also, I think three-wheeled forklifts didn't fit well in the main line. But you can see this is what we're trying to achieve. And so our focus is not on all things related to lean manufacturing. It's how do you design your value stream from a workflow perspective, line balancing, flexing, how do you handle different work content, et cetera, all those issues. That's what we call line design. And then we also have the other wing of the bird in order to get this bird to fly, which is mixed model material flow. So what we're talking about here is supply chain, external suppliers, linking them with pull systems, getting the parts to the factory, and then delivering them efficiently to the point of use in very small quantities, or even one unit at a time, kitting strategies. So that's mixed model material flow. And then we have the Lean Design Simulator, which we use to model those systems that we're designing. So we have menu sections here for line design, material flow simulation. Roadmaps are implementation guidelines. In other words, it's not just learning about mixed model line design, it's how do we do it? And what are the work steps? What are the deliverables? That's what we see here. And then we have tools and AI. So I'm starting to get into AI related tools as well, as is everyone else, by the way, everyone else in the world. So I'm going to go over here to the tools and AI menu option. And we're going to launch the simulator or the benefits calculator from there. So in web-based tools, spreadsheets, we have a bunch of training we did on using AI in a lean environment. And then we have some specific tools. So process commonality analysis tool, build models with one click, doing the lean math. This is a tool to help calculate, as it says here, the total cost of procurement. If you're thinking of outsourcing parts, for example, what is the real cost of that? And which may be a good idea or maybe not, but you don't know until you actually calculate the total cost. And then we have quick changeover benefits. If you just have a quick changeover project, what would be the potential benefit of that? And then we have the lean benefits calculator. This is one we're going to be looking at here. Also on this page, we have the ability to download our book, and we have some AI examples. This is an experiment I did recently, created a private AI, a private chatbot, and this particular tool will allow you to say something like, give me 10 questions on how to sequence demand on a mixed model line, give them to me one at a time, and give me a score at the end. Give me a multiple choice or essay question. It'll vary the question format to test your knowledge on line design. Okay, pretty cool. All right, so let's go. I'm going to go into open the lean benefits calculator. And this is the same one that you can see on your side. All right, can we see it here? Yes. And let's just use it. I'm just going to enter in some made up data, and you can see how this would work for you. Okay, so and this works a little bit, if you've used TurboTax, this works a little bit like TurboTax. It's a wizard, right, and walks you through the steps. So we have, you can see 11 steps here. We have company data and then 10 other benefit categories that we want to look at. So to get started, every page, every tab here of the 11 has a little audio help. So if you click on this, you get to hear an audio explanation of that particular tab and what's expected. Also, you'll see the little question mark here, and when you hover over that, you'll also get some help popping up to tell you what's expected. So I tried to put in a fair amount of help for using this tool. No manual, right? So all the help is kind of built in. So what we do here is we set up our benefits program. We'll just give it a name, and we'll give it whoever's working on this, your name, and the date that you're doing this, and then you'll need an email address. So I'll just put in my address, let's say. It won't let you get beyond here. There's a little star asterisk here. That means it's those two things are required for you to go forward. Okay, so pretty simple, so not much there. Also, let me explain what's happening over here on the right. As you go through the different benefits, it's going to keep a running total of where you're at. And there are two types of benefits we're keeping track of. The first one's called cash flow benefits. These are for the kind of benefits that don't necessarily impact your profit and loss statement, but are still good to have. For example, if you reduce inventory, you haven't sold more product and you haven't cut costs necessarily, although you have in another way that we'll look at, but you freed up some cash, right? So if you have $1 million in inventory and you free it up by selling the product and not having to replace it, basically, you now have $1 million in cash that you liberated. And so that's a definite benefit, but it's different from a profit and loss type of benefit. So we're keeping those separate. So as we go through these different categories, it's going to keep a running total with the grand total here at the top. So you can kind of see how we're doing as you go through the different elements, right? So let's get going here and let's just make up some data. So I'm going to shift this down. All right, the first one is direct labor. So this is a big one. And you'd expect to see direct labor impact from a couple areas. One is simply improving the process, doing a better job of staffing and line balancing, having a well-staffed line based on a mixed model process that we teach. So the number of direct workers could potentially be impacted there. Also, if you're improving error checking, improving the process itself, then you're going to need fewer people probably because you're doing less rework and those kind of activities. So lots of opportunities. And one of the biggest ones that is often either not known about or not practiced is something we call flexing. So if you have a line and your workers cannot flex that, by flexing I mean work at more than one location, move, then basically you can't run the line unless it's fully staffed. And that's pretty common, right? That you couldn't run an assembly line unless you have a person at every station. But if people are trained and are able and willing, willing's a part of it as well, to flex, then you could actually staff an assembly line with less than fully staffed, and people would just move based on a methodology that we teach, move to open stations as needed to keep the product flowing, but you could run it with fewer people. Now, you're not going to get the same output with fewer people than you would if it was fully staffed, but maybe you don't need it, right? So if demand has gone down, you don't have to redesign or rebalance the line. You simply leave the line just the way it is, but have fewer people. And so that can be huge. The other huge benefit of flexing is this. In a mixed model line, products are not all the same, right? You have different work content potentially coming down the line, one after another. In fact, at Toyota, basically every fork truck coming down that line is different and takes a different amount of time within limits, but a different amount of time to build. And so if people can't flex, then you're going to have times where a person can't work because they can't move the unit out of their station. Remember, we're trying to do work one at a time, single piece flow. One by one production is part of our goal. But if you have variability, then that one by one production will drive either workers being blocked, so I can't move it out of my station because downstream they're taking longer, or starved, right, or waiting because I've got an open station, but I don't have anything to work on because upstream they're taking longer, right, to get the unit to me. So if you add up enough of that, that's lost productivity. But if people can flex and move, then they can move to where the work needs to be done and overcome to a certain extent the imbalances or variability that would occur if you were fully staffed. So this can be huge. In fact, I don't think I have it in my bookshelf that I'm looking at here, but there's a guy named Gordon Guérin who wrote a book on this you might be interested in looking at called Self-Balancing Lines. You can find it on Amazon. Where he talks about this, and he said that in his experience, and he kind of, I don't know if he specializes in this or just does it a lot, but he said in his experience, he's rarely seen less than a 30% productivity gain if you're going from a fully staffed environment with variation to a flex environment. And that is huge. Okay, so enough talk. Let's see how we would calculate this. So we're going to estimate with a slider. One reason this could be done, by the way, this benefits calculator could be redone if you wish in Excel. It wouldn't be that hard, but this way I can use some of these cool tools like sliders and so on. So I'm going to slide to direct workers, and let's say we have 200 direct people, and those direct people could include material handlers as well, right? So we're not saying material handlers are not direct. And then we put in an average hourly rate. What we're trying to do here is estimate the payroll cost, the direct labor cost. So maybe let's put in a number like 25. That should be the fully burdened rate, by the way. That's what the company's paying for. So if I put in $25 an hour times 200 times 8 hours a day and 240 days a year, then we have an annual payroll estimate of $9,600. Now, if you actually know what that number is, then you could just tweak the numbers here and get that number into the lean benefits calculator. If you don't know what it is, then you're going to develop a rough estimate. And let me tell you too that this tool is intended to be a kind of a back of the napkin approach. It's not intended to be hyper accurate necessarily. It's intended to give us an idea roughly of what we can expect. So you may not always have the data that it's going to be asking for as we go through this, but if you don't have that data, then take an educated guess, I think is what I would recommend. Get in the ballpark of what you think these values are, or if you have to, go do some research, or leave it zero, right? If you have no idea, you can just leave it as zero benefit. But if you sense that there is some benefit, I would recommend that you include at least something, even if it's extremely conservative, right? Now, once we get the basic baseline data entered here under direct labor, then we need to have some estimate of the impact we expect. And again, this is a value judgment. If you're going from a fully staffed line to a flex line, again, Gordon Guérin saw never less than a 30%, but that's going to be maybe hard to believe. But if you're going to a flex environment, there's going to be some productivity improvement for sure. So again, recommendations, be conservative. So if I slide up here to, well, gee, Gordon Guérin said 30%, but knowing what we know, I'm going to say 10% is what we're shooting for, what we can expect to see. And then on top of that, we've got a better balanced line, People are going to be trained. You know, all the things that impact the labor piece of this. We expect to see some benefit there as well, right? Maybe I'll give you another example of the kind of benefits we would see that impact labor. If you're currently your direct labor on the assembly lines, if that's what you have, are getting their own material, what would happen to them if we could deliver the material to them kind of like a surgeon, right? The surgeon in an operating room puts out his or her hand, and the tech or the nurse, the head nurse, puts the tool right into their hands. If we can do that in the factory, which is, again, what Toyota is doing, then that person on the line is going to have more time to actually do value-adding work, building the product. And so if we're making those kind of changes, then we would expect that productivity level to just go up. And if we're improving the quality, then we're going to have less rework. So it's going to go up. So the main message here is we want this to be a conservative and something you can defend, right? If your boss says, where did that come from? You have a story to tell. You want it to be conservative, though, because in our heart of hearts, we think it could be actually much greater than that. But let's be conservative with all these estimates. So if it's 15% and we have a $9.6 million labor budget, then our expected benefit is $1.44 million in labor savings. Now, we're not saying here you now have excess people, right? Presumably, those people are not getting laid off. These people are being redeployed, right, to other areas, or the headcount adjustment is made vis-a-vis just normal attrition, right? But we don't want to use this as an excuse to lay off people. So those results are going to show up now in this P&L benefits up here at the top. So we now have 1.4 million. Excellent. Let's go on to the next one, floor space. So I'm going to click on, I'm going to click on next, and we're going to go to the next one. So floor space. So this floor space is in the target area. And when I say target area, the implication is that we're not doing these benefits necessarily for the whole factory. We're looking at a project. So it could be an assembly line or some specific area. And we want to have some idea of what we would expect in terms of floor space savings. Now, where are these floor space savings going to come from? Well, they're going to come from a re-layout that's going to be part of our project, where we're going to put things closer together, presumably. We're going to put in the correct number of resources, and we're going to take advantage of opportunities to make things more compact. This other area, which can be huge, I mean, really huge for floor space savings, is we're going to reduce the amount of inventory within our new environment to potentially much smaller quantities than maybe you're used to. For example, our recommended amount of inventory at our workstations is going to be no more than a few hours of usage. And our inventory in our supermarkets on the factory floor, no more than a day or two in those areas. And this is a stark contrast to practices in the past where people would deliver a whole huge pallet load of material to the assembly line. And that the mentality was, well, if I do that, then I don't have to refill it anytime soon. Yes, but we want to refill it often, and we're going to do that with a redesigned material flow system that actually delivers in small quantities, but maybe much more often than you're used to. So that's what we're going to do. So floor space, again, develop that data if you need to, but let's put in 100,000 square feet, and then we need to have some idea of what's the cost per square foot. Actually, I didn't put in feet here, so it could be, if you're used to thinking in terms of meters, you can use that as well. It doesn't care. But what is how many square meters you have, and what is the cost per meter if you want to use that unit of measure? That's why I said unit of measure rather than feet. So if it's $5, that sounds pretty cheap, but $5 per year. Okay, we're using a yearly time frame. Then we have $500,000 in cost, right, for this area. 100,000 times 5, and that's what we see here. How much do we expect to reduce? Again, this is going to be a value adjustment, but if you do all the things I just described, then I think it would be probably not too hard to come up with some idea of what space reduction you can expect. If the workstations are closer together, you're able to move parts one by one, and the amount of material you have at the stations is potentially much less. You'll have to come up with some estimate. But if you drag this to the left, it's going to calculate reductions as a percent in floor space. So if we say, pretty conservatively, we can save 10% of the space by doing a better layout and putting things closer together and having less material, then that would generate for us a $50,000 floor space savings. Now, that's potentially a sunk cost already, right? We already have a lease for that 100,000. So some people may challenge you on this and say, yeah, but we can't, it's not actually a savings because we still have to pay it. Yes, but if this could avoid having to expand or acquire new space, that's definitely a bottom line savings, right? You can avoid having to acquire additional space because you've freed up space you have. And even the space that you have is going to result in more productive use, within the space that you're using, because you're putting things closer together, you're minimizing material, less confusion, better communication. So, I've left it here as a P&L benefit, but again, we understand that you may have sunk costs, right, involved here, like a long-term lease that you're not going to get out of. And by the way, when you actually free up space like this, you want to protect it, because if you leave open space out on the factory floor and don't have a fence around it, then people are going to use it to put things in, and you don't want that. So you need to protect it and then maybe find a better use for it as you go down the road. All right, let's move on. Work in process. So we have 3 inventory categories we're going to look at. The first one is work in process. So work in process is definitely going to go down if you're going to a one at a time flow line compared to maybe other ways of doing work. One of our goals in our line design is to eliminate accumulation of inventory, right, between workstations or between processes. Link and balance the work, create this river system. So you may have to go to accounting to get this, but if you kind of know what your current inventory, WIP inventory is, work in process, let's say $235,000. Now, how is this going to go down? Well, primarily it's going to go down through reduction in lead time. Because think of it this way, if it takes 5 days to get a product through the factory, then you've got 5 days of work in process, right? But if you can redesign it based on mixed model manufacturing principles and get that from 5 days to 3 days, then you've actually eliminated 2 days worth of work in process inventory because things are going through faster. So that's kind of the basis for how we're estimating this here. So if we had 5 days in the current state and we go to 3 days in the future state, and we're going to apply something called cost to carry inventory. So let me tell you what that is. So if we go from 5 days to 3 days, then our inventory based on these numbers is going to go down by $94,000. And you see it up here, cash flow benefits, $94,000. That's great. But the cost to carry means this. Reducing inventory or having inventory is not just a matter of the cost of the inventory. There are all other savings, benefits from reducing inventory, because inventory has to be counted, it has to be stored, it takes up shelf space, it can go obsolete, it can get damaged. In some industries like electronics, it's inventory that's around too long is really at risk of being obsolete. Aerospace is a similar environment. You don't want things sitting around and not being used in your products, because sooner or later it's going to be designed out of your product, right? So especially, as I said, electronics or high-tech environments, that's a serious risk. So each company needs to come up with a cost to carry estimate. Again, cost to carry does not show up on your profit and loss statement. It's an estimate that you use of the potential impact of reducing inventory by reducing all these other categories, not having to cycle count, not having to store it, not running the risk of it, getting run into by a fork truck or run over by a fork truck, and not incurring the risk of obsolescence, all those things. So come up with a number. Again, it's going to vary by industry. Some industries, maybe the inventory will last longer, so to speak, So the more risk that inventory has, the higher the cost to carry value you want to use. In this simple example, I use 10%. I think 10% is probably a conservative estimate of the annual cost to carry. So that flows down to $9,400, and that's the value we're using on the P&L. Now, again, you're not going to see that number on your profit and loss statement. There's no category that says cost to carry inventory, but we know it's real, and you don't want to ignore it, right? You don't want to not include that in your estimate. All right, next one, finished goods. So finished goods impact on finished goods may be zero. If you don't actually have finished goods, then I think it would be zero. Like if everything you ship is to order and it just goes out the door to the customer, then you may not have any benefits. But if you actually have to hold finished goods, then there are techniques we can use to reduce that, lean strategies to reduce that and get some benefits as well. Example I can give you is we worked with a company that was making blood glucose monitors in California. Where you prick your finger, those little units, and basically they had to carry a certain level of finished goods inventory because when they got an order, they had to ship right away. So they couldn't build to order; they had to basically ship out of stock, right? Finished goods, and they had some. I don't know what their systems were, to be honest, to calculate how much they needed, but they had some software that helped them manage that. But what we did was we replaced that system with a Kanban system, finished goods Kanban system. So as units were shipped out of inventory to customers, that would liberate a Kanban card that would go back to production to trigger, building more, to restock finished goods inventory. So that was easy. And the result was they went from the numbers I recall, and this has been more than a couple decades ago, to be honest, but it was something like 8 million to 2 million, basically overnight. So that was a nice we hadn't expected it or really included it in our original estimate. So if we have, make up a number, $300,000 in finished goods inventory, and we can, through a Kanban system or better management or you name it, some other techniques, we can reduce that, then we would expect, some percentage reduction here, let's say 20%. That would be pretty modest, but $300,000, same cost to carry. We've got $60,000 reduction in finished goods and $6,000. So you can see the cash flow benefits are adding up here, accumulating, and the cost to carry P&L benefit is showing up over here, right? It's kind of similar to what we did before. Last one is raw material, kind of the same thing. So we've got raw material inventory. Let's say, I'm just making up numbers here. I'll just type in some random values in raw material and change in raw material percentage. Now, where is this going to come from? This is going to come, and this could be big, but this reduction is going to come from basically implementing pull systems for material, like Kanban systems, which are going to set the level of inventory that's allowed on the factory floor, because you can't have more than the number of Kanban bins that you set. And it's also going to potentially impact raw material in your warehouse when you start linking Kanban signaling or pull signals to outside suppliers. That's where the big one is. Certainly, you want to start with your own factory first, right? You don't want to be telling your suppliers to jump through hoops that you don't do yourself. So implementing a pull system on your factory floor is your starting point, but I think the big dollars come when you can extend that beyond to your outside supply chain. And this is what, of course, many companies do. Automotives, does this. Toyota is a master of this, but it's not something that happens overnight. Typically, you have to work with these companies, outside companies, and really determine, give them a forecast, determine their lead times, help improve their processes potentially, and then be able to get them on a milk run kind of relationship. And of course, the closer they are to your factory, the better from this point of view. So based on your knowledge of what you have planned and what you're going to be doing, you can, again, drag this to the left and project the impact on raw material. And it's going to do the same kind of calculation we saw before. And you could have different cost to carry numbers here for each of these categories, but in this example, we left it at 10. And you can see everything starts updating or continues to update here over on the kind of the status box. All right, next one, overtime expense. So if you're currently incurring overtime, and you can get that measurement, those dollars. How much are we paying in overtime? Well, if you do a better job of managing your lines, able to overcome variability through a robust mixed model line, you would expect overtime to go down, right? I don't know why it would go up. So overtime would go down. So again, be conservative, but if you just ignore this, then you're ignoring some potential benefit. So even if we say 10% reduction, that adds up. So in this case, if we have $392,000 in overtime and we can improve that by 10%, that's $39,000 that we can add to our list here, right? Overtime reduction. So that's pretty straightforward. So you can see here that a lot of these benefits require some idea of where you want to go and what's possible, right? There's some actual data here from your company, but there's also a value judgment in terms of what we can expect to achieve. That's why I'm saying these numbers are going to be conservative or should be conservative. Okay, MCT reduction. So MCT stands for manufacturing cycle time. So this is the river system that we talked about earlier, that I mentioned earlier, that Taiichi Ohno was trying to implement. So I'm pulling these numbers from, we used it previously, right, under direct labor, I think. So we have our current state MCT, 5 days, our future state MCT, 3 days. So that was taken from a previous benefit. But what we want to add here is some estimate of what is this worth to us? Because when we reduce lead time like that, there are all kinds of benefits that we expect to achieve. Like one of them is the work in process inventory that we talked about, but also our ability to respond to customer requirements more quickly is hugely beneficial. Our ability to plan more closely, to the actual due dates for these various orders. So what you're being asked to do here is come up with an estimate of what is this actually worth to us per day of reducing that MCT. I can refer you to a book that discusses this benefit in a lot more detail. It's called you may have heard of it. It's called Quick Response Manufacturing by Rajan Suri. So again, I'm mentioning some books you might want to look into. This is not a quick read. This is like 600 pages or something, but a lot of the discussion here is the value that we're talking about here on this one. So if we put a number, I'm again being very conservative, let's say $30,000, every day I can reduce that customer response time, right, or that manufacturing cycle time. $30,000, so reducing it by 2 is a $60,000 benefit, right? And again, it was added here to our list. All right, we're getting down there, a couple more to look at. Quality improvements. So this implies that you know what your current cost of quality is. What we're talking about here primarily is scrap, rework, those kind of costs. And if you're keeping track of those, then you can put that number in here. So currently, our current state is this number per year. And we expect to improve, right? Because we're going to have robust standard work definition. We're going to error-proof the process. And one of the techniques that we're big fans of is called check, do, check. So what we're talking about here is an environment where people don't just do work and pass it on. They check their own work, and they also check the work coming to them before they do their own work. So the first check, the check, do, check. So the do is doing their work. This applies to every worker in an assembly line, for example. So the first do is when work comes to you, there may be some key quality attributes that you want to check. Because if there's a mistake that was done upstream, you don't want to keep doing work on it, that you have a defective unit in front of you. And so you need to kick it back or have some corrective action that needs to take place. So if the unit is good, then you do your work, that's the do. And then the last check is you check your own work before you pass it on. Just something as simple as that takes a little bit of extra time and can have a huge impact on the quality going through at a very low cost. It's basically free. Or you may have more sophisticated poka-yoke error proofing techniques. I almost said idiot proofing, but I didn't want to say that. So error proofing techniques that you build into the process. And you can do this at the design stage. When you're designing this, And the goal, of course, is to move products through the flow with no errors, no defects. And this is really in stark contrast to what, say, the automotive industry used to do back in the 50s and 60s, where the philosophy was never stop the line. So never stop the production line. And so basically units with defects would be allowed to go through, and they would have sometimes a huge area at the end where they were doing rework. So what kind of improvements can we expect? Well, again, you know your own environment better than I do here, but again, the slider here will let you put in a certain percentage that you would expect. Again, be conservative. So then that number shows up and is added to our list. And then we have sales impact. So the question here is, if we make all these improvements, we reduce our customer response time from 5 days to 3 days, for example. Do we expect any impact on our customers? Our customers going to be happier, maybe buy more for us, improve our sales. So it's the revenue side of things. And so we would have some estimate of how much revenue is this production line actually generating for us? Like 2 million. Is that 2 million? Yeah, 2 million. Let's say $2 million in revenue. And if we can deliver more quickly, are we going to be able to improve on that? And better quality, right? Why do people buy Toyota cars? It's not because they're the sexiest car in the world, and it's not because they're the cheapest car in the world. It's because people rely on them, right? They are buying quality, basically. At least that was I have a Camry, very, middle of the road standard car. But what motivated me was I don't want to have to be taking it to the garage all that often. So we have this, and if your answer is yes, I think we can expect better sales, then you put some number in there, and then that flows through as before. We're also putting a profit margin here. So on this line, it's not just revenue, but it's what is our estimated increase in profitability. That's really the number. How much money, if we make this change, how much money is left over, in terms of profit? So $15,000 based on this. But obviously, if you expect something bigger than that, the number just keeps going up, right? And then the last one is opportunity cost. So opportunity cost here is really focused on, okay, if we don't do this project, or if we take too long to do it, what are we missing? Well, we're missing, taking advantage of these benefits and maybe others. So we want to get some idea of how much money are we flushing down the toilet, basically, by not taking action quickly. Instead of doing things now, we're saying, well, we'll put off this project to next year. So again, we're coming up with an estimate based on your lean professional experience of, I am flushing down the toilet $100,000 a month by not taking advantage of this, right? So if I'm delaying this project by 3 months, that's a $300,000 cost, or it's a benefit that we could gain by doing things now, or doing things sooner. So again, this is something that may be harder to understand, and you can just certainly leave it at 0. But I always see it as something really important because if you believe these numbers here, so you have $391,000 in cash flow benefits and over $2 million in profit and loss benefits. If that is anywhere close to being true, then why do you want to just screw around, right, and not take action? Okay, so there's a last button, finish. And what you need to do here when you finish is, well, click on finish, because if you don't click on finish, then you're not going to get the results. When you do click on finish, there it says success, form was sent successfully. So what will happen is you'll get an email with your results, right? With the numbers we just saw. And again, this is the only place that this is actually, let me get back to my slides. This is the only place that the information will be stored then, will be in that email. Okay, so that's it. You guys have full access to it. Send me your ideas. I know when I was going through this, I did come up with some other ideas things that could be added. I thought that flexing was so important that maybe it should be a separate, separate category to focus on that, on flexing. But I didn't have time to really modify the benefits calculator. But if you have any other benefits you think are significant that should be included, we can make this a better tool. And if you don't want to use this at all, you can certainly develop your own. So remember, it's leandesignstudio.com/lean benefits calculator. LBC is the URL. You might want to jot that down. Now, a couple announcements here. We have the next mixed model line design. If you want to know how to actually achieve these benefits in a structured way with a high level of confidence that you're going to actually achieve them, then you need to embrace mixed model manufacturing, which is another word for basically how Toyota develops their lines. And this is why Toyota has been willing to have us come and use their training facilities in their factory in Columbus, Indiana. So the next one's coming up. It's February 20th to the 22nd. And here are the two links to find out more about these two workshops. That's the line design, and then the material flow. The one focused on material flow is on April 30th through May 2nd. Includes factory tours and all these good things. And then we have two others later in the year. Those are not open yet for registration, but the first two are. So if this is something of interest to you, by the way, we only have about 6 seats remaining on the February class. So it's almost sold out. But if you get excited and want to go, you can probably get in now for a few people. All right, so I think that's all I have. So I look forward to to hearing from you if you're using the Lean Benefits Calculator. Again, if you have ideas for improving it, I'd love to hear those, and we can actually make it better. Or if you have problems with it, I want to know that feedback as well. Here's our contact information. We'll send you an email. You'll also be getting an email from this webinar in terms of replay link if you want to look at it again.